Okay, so we're going to look at tangents, and I suppose there's a few things to remember about a tangent. And basically, first off, I suppose, is just definition. So a tangent is a line that touches a circle at one point only, so that's quite important. Only one point of tangency or one point of contact. If a line is tangent, then the perpendicular distance from the tangent will be equal to the radius. Okay, and all of that kind of coming from similar theorems that we've looked at before to do with, I suppose, the radius. The radius is always perpendicular and perpendicularly bisects the chord. So again, if I have a tangent point here, the same idea kind of applies, that I can show that that radius line is going to be perpendicular to the tangent at that point. That particular rule is quite useful for us really across all of these questions, to be quite honest. That's probably the one rule out of all of them that we end up using the most of the time. So let's kind of look at the different options that we have. So it's split under, I suppose, some of the different ways that this kind of question can be presented. So first of all, finding a tangent at a point on the circle. Okay, so if I'm given a question where it says this circle has a tangent at point P, find the equation of the tangent, the main thing we're going to be using is that that tangent must be perpendicular to the radius at that point, where of course we know the radius is the line between the centre and my point of tangency. So if I can find the equation of that line, then I just need to find the line that is perpendicular to that. So even the slope will do for that, and then note that it goes through point P. So find the equation of the tangent to this circle at the point P, 3 minus 1. So let's have a little look. The point that I'm going to be using for my tangent is point P, 3 minus 1. And the slope, or the thing that I'm going to be using for the slope, is that it's perpendicular to the radius at P. Okay, so if we kind of construct, I suppose, our diagram basically the same as that kind of sample sketch that I have there, with tangent line touching the circle would be better. Okay, that'll do, lovely. Okay, this can be my point P here, and this is my center. So first thing we need to do is find the center. We should know that when the equation of the circle is written in this long format, we look at what number's in front of x, that is 2g. So 2g is 2, g is 1, so minus g is minus 1. 2f is 4, so f is 2, so minus f is minus 2. So my center is minus 1, minus 2. Okay, I want to now find the slope of this radius line from C to P. So that's y2 minus y1 over x2 minus x1. So that's minus 1 over minus 4, which is a quarter. That's going to tell me then that the slope that's perpendicular to that, okay, my perpendicular slope, is going to have to be minus 4. Okay, my perpendicular slope is going to have to be minus 4, and that's my tangent line, so maybe we'll call that one t. So now I know that the slope of my tangent line is t, and the point it's going through is 3 minus 1. I can find my equation of my circle using our usual equation of the line formula. So y minus minus 1 equals minus 4x minus 3. Y plus 1 equals minus 4x plus 12. And we get 4x plus y minus 11 equals 0. And that is the equation of the tangent. Okay, so quite straightforward, really, compared to some of the questions that we've done. I suppose it does naturally then get a little bit more taxing on us as we go through the different types. So the next type we want to look at then is a point that is not on the circle. Again, still using the same rule, but having to rephrase it slightly differently now. So my point P, as we can see in the diagram, is no longer on the circle. So the lines, that kind of creates now two possible lines, because we can see there, I could have two lines that are tangent to my circle, one above and one below the circle. And in these questions, then that's kind of why we nearly end up with two possible answers. Now, the main thing that's going to determine those two answers is actually the slope. Is actually the slope of those two lines. So we're going to let the slope be m. We are hoping then that we will end up with some sort of equation that relies on m. Okay, some sort of equation that is based around m that's going to give me two answers. So I need to find the general equation of these two lines, just leaving m as unknown. I'm going to also use the perpendicular distance, the fact that I know that that should be equal to the radius. So the perpendicular distance from these tangents to the center should be the same as the radius. And I'm going to then solve for my slope m. So let's just see that in action then. So find the equation of the tangents to this circle from the point 6 minus 1. So let's have a look at the center then. So 2f is 2, 2g is 2, g is 1, minus g is minus 1, 2f is 8, f is 4, minus f is minus 4. Okay, so I'm looking at center minus 1 minus 4, radius 1 squared plus 4 squared minus 8, so 1 plus 16 minus 8, which is going to be 9, which is 3. So radius of 3. Okay, whether I need that, I suppose we see as we go forward. So let's let the tangent have slope m, goes through, and it goes through point P, which is 6 minus 1. So to find the equation, y minus 1 equals mx minus 6. And we're just going to try and tidy this up, I suppose, as best we can, knowing that we're not going to be able to solve for m here. Okay, so knowing that we won't be able to solve for m in this case. Now what we're going to use is we're going to use that the perpendicular distance to the center from that tangent should be equal to the radius. Okay, so if I'm going to be subbing into my perpendicular distance formula, I need to make sure that I can properly identify each of the letters in that formula. So A is going to be the coefficient of x, which is m, B is the coefficient of y, which is minus 1, and then C is going to be whatever's left, which is this longer expression, minus 6m minus 1. So subbing into my, I suppose, perpendicular distance formula here. Okay, we can go to our log tables to make sure we know that formula. And I'm going to show that that is equal to the radius. So subbing all these points in here, then m by x1, the point I want to use is the center. So the center is minus 1 plus, or sorry, minus 1 for B here. And the other center point is minus 4. C we said was minus 6m minus 1 all over m squared plus minus 1 squared, and that should be equal to a radius, which is 3. So I have minus m plus 4 minus 6m minus 1 all over m squared plus 1 equals 3. So minus 7m plus 3 all over m squared plus 1 equal to 3. Okay, so end goal here now is to try and eliminate this modulus. So we should hopefully remember that to eliminate the modulus, the main tool we have for that is to square. So, and that's going to help me with my square roots here as well. So squaring both sides, I need to make sure with my modulus that I do actively square both sides here. And this is going to be 9 from the 3 squared, and the squaring the square root will just eliminate the square root there. Okay, so multiplying this out now, 49m squared minus 42m plus 9 equals 9m squared plus 9. So that's going to give me 40m squared minus 42m equals 0. Taking out a factor here, we could maybe factor 2m, would give me 20m minus 21 equals 0. So I get 2m equals 0, or m equals 0, and I get 20m equals 21, or m equals 21 over 20. Okay, as my two possible slopes that I could have here. Okay, so a funny, I suppose, case for us here, but just to show that we don't always necessarily end up with those kind of strict values for m here. Now, we should hopefully recognize that a slope of 0 is kind of suggesting a kind of vertical line there for us. So let's kind of see how that works if we sub back into that equation of the line that we had. So the equation of the line we had there was mx minus y minus 6m minus 1 equals 0. So 0x minus y minus 6 times 0 minus 1 equals 0. So I get minus y minus 1 equals 0, or y equals minus 1. So we're ending up with a nice vertical or horizontal line, excuse me, there of y equals minus 1. So a nice horizontal line, which is going to be tangent to my circle. The other line that I have then is 21 over 20 minus y, or x, minus y minus 6 times 21 over 20 minus 1 equals 0. Multiplying across by 20 there is 21x minus 20y minus 6 by 21 is going to be 146. minus, sorry, excuse me, let's multiply that to make sure it's right. Okay, and multiplying that by 20 there, I'll actually just get rid of the fractions. Let's just go straight to that. Minus 20 here, and that's 21x minus 20y minus 146, all equal to 0. So I have two possible equations of the line, one being y equals minus 1, and the other being 21x minus 20y minus 146. Okay, so setting out a similar idea there, I suppose, using that perpendicular distance, using the fact that it's perpendicular to the radius, and the tangent and the radius are perpendicular at those points, and using that slope as unknown. So there was no way we could know it, and it is kind of the unknown for the question, so we just kind of go with it. We leave it as unknown, we see where it takes us. Let's keep ourselves ticking along a little bit here and look at the tangent parallel or perpendicular to a given line. So again, we're using that same idea, perpendicular distance from the center to the radius is to the line is equal to the radius. A line parallel to a given line is going to have the same format with just a different last value, a different constant value. A line perpendicular will be slightly different in that the a and b will be swapped with the sign changed on one, and usually we write it with the sign changed on the y. So we're looking to find the equation of the tangent of the circle, which is parallel to this given line of 3x plus 4y plus 10. So let's see what we can kind of take from the equation of the circle here. So finding my center, same way that we found the other ones, it's going to be minus 3 minus 1 here for my center. Okay, so minus 3 minus 1. Looking for my radius then as well. So radius is 3 squared plus 1 squared minus 15. So that's 9 plus 1 plus 15, which is 25, which is 5. Okay, so it could be useful for us there as well. What we're kind of looking for is we have a circle here and we want two lines that are going to be perpendicular to this other line that we have. So both these tangents are going to be perpendicular, or parallel, excuse me, to each other, and that distance to the center still should match up with the radius here. The two lines that I want, they have to be parallel to this line, which means the first case here, the 3x plus 4y, is going to be identical. And the reason for that, of course, is that the slope of this line is minus 3 over 4, taking my minus a over b, and we want each of these lines to have that same slope as well, minus 3 over 4. So the two lines I'm looking for should start with 3x plus 4y, and then some other value, which we often just call k. Okay, we tend to go with k there as our different kind of value. So the perpendicular distance to the center should be equal to the radius. So let's see if it is, using my perpendicular distance formula like we did in the last part. Plus 4 by minus 1 plus k all over 3 squared plus 4 squared, and that should be equal to the radius, which we know is 5 in this case. So multiplying all this out a little bit, so minus 9 minus 4 plus k all over, and I know 3 squared plus 4 squared, that's going to give me 5 squared, or 5 squared, so I suppose overall just work out to 5 there, which is kind of perfect for us in this case. So we have 5 here equal to 5. Let's kind of simplify all this down. So I have minus 13 plus k equals 25. Okay, to get rid of my modulus, I can square both sides, but because we have a nice just normal value on the right hand side here, we can save ourselves that trouble a little bit by saying that this means minus 13 plus k, the kind of middle section in the modulus, must have a value of plus or minus 25. So minus 13 plus k being equal to plus 25 means that k is equal to 38, and minus 13 plus k equals minus 25 means that k is equal to minus 12 for myself here. Okay, let me see why it's not coming across for me. So minus 25 plus 13 is going to give me an answer of minus 12 then, as my overall result there for that question. Okay, so it kind of saves, I suppose, a little bit of trouble there in actually having to work out those values to some extent. It just kind of makes things a little bit easier for us in solving that question. Okay, so the last little part that we have to look at, or sorry, to finish that one out, it would just be to fill in the equation there. So 3x plus 4y plus 38 equals 0, and 3x plus 4y minus 12 equals 0. Okay, so the last little part to look at then is just the length of the tangent. I've tried to mark it in here again in our diagram in as clear of a way as possible. Again, we're using that same idea, tangents perpendicular to the radius at that point of tangency. So the main things we need to do is find the length of the radius and find the distance from the center to this point that's off the circle. And if we find those two, we can use Pythagoras' theorem to find that distance PT, which is the length of the tangent line. So find the length of the tangent from P to the circle. Okay, so let's fill out what we know and kind of go from there. So my center here is 2, 5. My point is 7, 8, which would actually be over this side. So let's put it in over here. I have a tangent going somewhere. So let's just say that, for example, it's going here through this line. And I want to work out this distance here that I'm marking in pink. So from some point of contact here, which we could call T, over to my point here, which is called P. That's the distance I want to work out. So in order to do that, I need to make myself a little triangle, noting that the right angle is up here at the point of tangency. So if we take my triangle out here, to even just kind of make it a bit more explicit and to fill in different parts as we find them, we're noting that the one we're looking for is not the hypotenuse. Okay, it's not the hypotenuse. So let's start with the radius. Radius squared, when it's written in this format, is 16, so radius is 4. That could be marked in here because it matches up with the 4 over here. The other thing I need then is the distance from C to P. So using my distance formula, that's going to be 7 minus 2 squared plus 8 minus 5 squared, which is 5 plus 3, 5 squared plus 3 squared, so 25 plus 9, which is going to give me an overall answer of root 34. Okay, that's for this answer here. So using Pythagoras' theorem, c squared equals a squared plus b squared, root 34 squared equals 4 squared plus b squared, 34 equals 16 plus b squared, and b squared then is 34 minus 16, which is 18. And b is square root of 18, which we can see if that breaks down to a smaller surd for us, 3 root 2. So the length of the tangent there marked in pink is going to be 3 root 2. So that's just, I suppose, a quick run through all of the different types of questions we can have relating to tangents. We do see more of those even in finding the general equation of circles. We see them in finding the equation when it's touching the axes. We see similar kind of methods and tools coming in. And I'll do a separate video then just going through those exam questions then from that section.